Hello, my name is Steve. Welcome back to my YouTube channel. In this video, I'll do the chapter 13 review about motion, force, and projectiles in Mathematics Extension 1. Here are 3 parts in this chapter, but overall, this chapter is all about how we can use vector to solve some specific physics problems. Okay, the first part is about displacement and velocity. There's one thing we have to keep in mind is that the average velocity doesn't equal to the average speed, because the velocity only consider about the position of the object. If the object travel in a circle, if travel one circle around, the object is going back to the starting point, right? So the displacement of the object doesn't change, which means the average velocity is 0, but the speed would consider about the path of the object travel. So we can have the average speed, but we can't have the average velocity. Okay. The second part is about force. In this part, we have to keep in mind is that we use the Newton's first law of the motion all the time, because when an object is kept at rest or keep in the motion with the same velocity, which means all the force applying on the object is balanced, unless some unbalanced force applying on this object, then the motion of the object will be changed. Okay, so for example, here is an object hung on the wall with 2 strings and 2 force from the string and another force from the gravitational force. Okay, so 3 force applying this object are balanced. Okay, which means in the 2 dimension, here's x and here's y. So all the force on the x-axis are balanced, and all the force on the y-axis are balanced as well. Okay. The third part is about projectile. In the projectile, when the object is projectile out, there's only one force applying on the object, is the gravitational force. Okay. So with if the object is projectile with the angle alpha to the horizontal, then the magnitude of initial velocity times the cos theta is the velocity on the horizontal. And if the magnitude of the initial velocity times the sin alpha will be the velocity on the y-axis. Okay, so there we have another gravitational force applying on the object. Is going down. Okay, so I will choose 3 questions for us to practice in this chapter. Okay, let's have a look at the first question. Question 1. On his way home from training, Mitch walks along 3 streets. The first one, he walks 150 meters north, and then 300 meters east, and then 250 meters north. The magnitude of Mitch's resultant displacement, okay, ask for the displacement, is one of these. It's quite easy to solve this question using vectors. Okay, I'll demonstrate to you how to use vectors. Okay, first of all, he walks north 150 meters, right, and then walk east 300 meters, and then turn to north with 250 meters. Okay, so the question asked for here is the displacement. So here is the starting point, here is the end point, right? So here is the displacement. Using vectors, we consider about this vector 1, or we can say here's vector A, vector B, vector C. Okay? So here's a vector A direction, here's the vector B direction, here's the vector C direction. So here would be the total displacement from S to N for Mitch from the training center to going home, right? Okay, so we can let or since here is a multiple choice question, we can say the displacement equal to A plus B plus C. Okay, so A plus B is starting from here, and then this one plus C would equal to this one. Okay. Right. Okay. What's A is for? A is just going north, right? So the vector for this one would be 150j. This for I. This for the vector A. Okay. Okay. Vector B just going to the east horizontally with 300 meters. So it will be 300 I only. Okay. C. C is going to the north directly. Would be 250j only. Okay, sum up all these three vectors would be, so I only we have one I, so it will be 300I plus j, so 150 plus 250 is 400j. Okay, the magnitude of the D is the displacement from this point to this point, right? Okay, the displacement would be 300 square plus 400 square, and then square root equal to 500. Okay, the unit is meter. Then the answer is C. Okay, using vectors to solve this kind of question is much easier than using a triangle to find this length and find this one. Much easier. Okay, let's go to the second question. In the second question, a soccer ball is struck with a force of 420 Newton force in the direction of north 22 degrees to the east. Okay, 22 degrees to the east. The northerly and easterly components of this force are F1 and F2. Vector S F1 and vector F2 respectively. The magnitude of this force are, so we have to find out the magnitude of F1 and F2. So we, on the diagram, it shows, so this is east will represent F2. So here is F2, okay? So the north represents F1, okay? So a soccer ball is struck with north 22 degrees to the east. So here is 22 degrees, okay? Going this way. So the question asks for the two component force on F1 and F2. Ask for this one and this one, okay? Okay, in this triangle, okay, here is 220. Here's 220 in this triangle. This F1 force would be 420 times cos 22 degrees, right? Okay, this force equivalent to this one, right? So in this triangle, this force would be sine 22 degrees and then times 420. Okay, just use a calculator, you get the answer. The answer is D. So on F1, this one would be roughly 389 newtons force. This one is roughly equal to 157 newtons force. Okay, the answer is D. Okay, let's go to the last question in this chapter. Question 3. A particle is projected from a point of 15 meters above the horizontal ground. So 15 meters above the ground. And its highest point, it just clears the top of a wall of 26.25 meters high and 30 meters away. Use the gravitational force 10 meters per second. Okay, so the first one is draw the diagram to show this information. So the particle, so here's the X and here's the Y, and the particle is projected from 15 meters above the ground, right? And then projected away, and then hit its highest point to clear a wall over here with 26.25 meters high and 13 meters away, okay, from here. Yep, so here's the diagram for the question 1, okay, so here. For the second one, find the expression for the velocity and the displacement, okay. Since we don't have any values for the velocity, so we can set the velocity at the x direction is vx, and in the y direction is vy. Okay, so let's set vx, the vector vx and vy are the velocity component at x and y axis. Okay, then if we present this velocity in a component form, would be vt equal to the I component would be vxi plus the j component would be vy minus the tan t. So here is from the gravitational force, okay? And then j component. Okay, so RT is the displacement equal to the integration of the velocity in terms of the t. Right? Okay, the integration of this part. Vxi plus vy minus tan t j dt. Okay, and then next step would be vx times t at I component plus vy t minus 5t squared. So the integration of 10t equals to 5t squared, okay? And then here at j component, and then plus c. Okay? So here's the RT. Okay, we have to find the value for c. We have an initial condition is when t equals 0, the particle is 15 meters above the ground, which means when t equals 0, in the I component is 0. In the j component is 15. It's 15j. So equal to when this one equal to 0, this one equal to 0, this one equal to 0, this one equal to 0. So here is the c left, right? So c equal to 15j. Then we have RT, the component form will be Vx times t at I component plus Vy t plus 15 minus 5t squared at j component. Yes. Okay, so we have done for the Vt and the RT. For the second question. Okay, let's go to the part C. Find the speed and the angle of projection of the particle. Okay, I'll write down over here. Okay, the particle is projected from here, and then hit is maximum height over here, right? At this point, the Vy equal to 0. And from here, we can find the time t of the particle. And because we have the position for the particle at this point would be 30i plus 26.25j, right? At this point. Then from here, we can find the Vx and Vy, and the t at this point. And then from these two Vx and Vy, we can find the overall speed of the particle at this point. Okay? So at here, when go back to the the velocity. here is the j component. When j component at this direction equal to 0, because at this point the velocity is equal to 0, vy equal to 0, then we can find this t, right? So when vy minus 10t equal to 0, the particle hit the highest. Hit its highest or maximum height. Maximum height. Okay, so when this one equal to 0, then we have t equal to vy minus divided by 10. Okay? Okay, from here, so the displacement at this point of time equal to 30I plus 26.25J. Okay? Okay, using this formula, here's Vx times T. So we don't have the value for Vx now, so let's keep it. We have to find the Vx. And then times T. Here's the T. So Vy divided by 10. So here's the I component. And then plus the J component would be Vy times the T, Vy divided by 10 plus 15. And then minus 5t squared. 5 times t squared would be Vy squared divided by 100. Okay, so here is J component. They are equal, which means 30 equal to Vx times Vj divided by 10. And these three terms together equal to 26.25. Okay, so we have Vx times Vy divided by 10 equal to 30, which means Vx times Vy equal to 300. Okay, so from here, Vy squared divided by 10 plus 15 minus 120 Vy squared equal to 26.25. Okay, so this one, combine this one and this one, we have 1 over 20 Vy squared equal to 26.25 minus 15, we have 11.25, which means Vy squared equal to this one times 20 would be 11.25 times 20 equal to 225, which means Vy equal to 15. Okay, 15 meters per second. Then, okay, write down over here. $15 meters per second. Okay, we get the value for Vy. Then from here to this one, we can get the value for Vx. Okay. Okay, I use the red color. Okay, so Vx would be equal to 300 divided by Vy, right? Equal to 300 divided by 15 equal to 20 meters per second. Okay. Then, okay. Okay, here. Okay, Vx is 20, Vy is 15. The overall V would be so the V0 equal to the absolute value of 15 squared plus 20 squared would be equal to let me check, plus 20 squared equals to 25 meters per second. Okay, this one is without any direction, just the magnitude of the initial velocity. Okay, and the second part of the question is we have to find the angle of the projection. So we have to find this angle alpha, right? In this triangle, the alpha equal to tan inverse of 15 over 20. So we can get the alpha from the calculator. Tan inverse of 15 divided by 20 equal to 36.87 degrees, or you can change it into minute, or you can keep this one. Okay. Yes, that'll be all for the chapter 13 review about motion, force, and projectiles. In the next video will be the last chapter review, chapter 14, about the binomial distribution. Hopefully my videos could help you to have a much better preparation for your HSC exam. If you like my videos, please give me a like and subscribe my YouTube channel. I'll see you in the next video.